Hello everyone, a very good morning to all of you. Welcome to Kishore Physics. Let us dive into the ocean of physics again. And in this lecture, I am going to tell you one of the most important topic, that is EMI, electromagnetic induction. And this is a very essential topic for both class X and class XIIE, both for CBSE and for ICSE. So it's my humble request to all my dear students, kindly make a proper note during my lecture. Okay, so in this lecture I am going to tell you the answer of 5 questions, mainly what is EMI, then I have to demonstrate the phenomena of EMI, and then we'll state the Faraday laws, and then what are the factors affecting the induced EMF, and lastly I am going to tell you the applications of EMI. Okay, so first come to this first question, that is what is electromagnetic induction. So let me tell you one thing. First you have to understand the flux. What is magnetic flux? This is actually a number of what? Number of magnetic field lines passing per unit area. So if the magnetic field line passing through a conductor, suppose the number of field lines that are changing, suppose, then what happens? If the magnetic field lines are changing, then definitely the flux will change. Okay, and that changing flux provide you the induced electromotive force, that is called EMF, right? So this is the basic concept or basic phenomena of EMI, correct? Okay, so then come to the second question, that is demonstrate the phenomena of EMI, right? So see, here I am considering one solenoid, right, and it is attached to the galvanometer, and see, it is very clear that there is no deflection at the beginning in the galvanometer when the magnet is at rest. Here it is north pole, south pole, but it is not in motion, it is at rest. That is why there is no any deflection in the galvanometer. Deflection नहीं हो रहा है क्योंकि मैग्नेट जो है वो रेस्ट है. लेकिन सेकंड केस को आप, फर्स्ट केस में तो कोई भी डिफ्लेक्शन नहीं हो रहा है, इट इज वेरी क्लियर, बट सेकंड केस में क्या हो रहा है देखो. When the magnet is coming towards the solenoid with a velocity v, then what happens? Here there is a current passing through the coil. That means there is an induced EMF here, and that is clearly obtained from the deflection of this galvanometer. Okay, and next see here again it comes closer and again it becomes a rest, and that is why it, again there is no any deflection in the galvanometer. galvanometer में कोई भी deflection नहीं हो रहा है. कब तक हो रहा है deflection? कब तक induced हो रहा है EMF? When there is a change or when there is a motion of the magnet, there is a change in its speed. You can say the motion of magnet induced the EMF, right? And in the last case, see, in case 4, you can see again, if you take away from the solenoid, if you take the magnet away from the solenoid, what happens? Again there is some deflection in the galvanometer, but it is in the opposite direction. Okay, so from this what you observe, actually a current flows in the coil only when there is a relative motion between the magnet and the solenoid. Okay. Okay, so what you basically observe here, if you reverse the direction in case 4 that we have seen earlier, the induced EMF का direction भी change हो रहा है, right? That is, let me explain another case. Suppose here it is the solenoid attached to the galvanometer, and now I am bringing the south pole, and here it is the north pole. See, mark the difference. Here it is the north pole, here it is the south pole. But now south pole is facing to the solenoid. So what happened? Definitely an induced EMF will be there, but it is in the reverse direction. रिवर्स डायरेक्शन में अभी इंड्यूस्ड हो गया. इसका मतलब क्या है? What we can observe here is that if you change the polarity of the magnet, the induced EMF also get reversed. Okay. Okay, so my dear student, I hope you are maintaining a proper note for this lecture. And now come to the next question, that is, state Faraday's laws of EMI. According to this law, what happens? If you are changing the magnetic flux, right, linked with a coil, then definitely you get an induced EMF, and the magnitude of that induced EMF is proportional to your rate of change of flux linked with that coil. And there is a negative sign here, and this is due to your Lenz law. Lenz law क्या है? According to Lenz law, जो induced EMF होता है उसका डायरेक्शन पता चले. इसका डायरेक्शन क्या है? If you want to know, it helps to find out. According to this law, the direction of induced EMF is in such a way that it opposes the cut that produces it. Okay? Okay, so come to the end of my lecture, end part of my lecture today. So, what are the factors affecting the induced EMF? क्या क्या फैक्टर है जो इफेक्ट करता है इंड्यूस्ड ईएमएफ? एक है रेट ऑफ चेंज ऑफ फ्लक्स, मैग्नेटिक फ्लक्स, एंड दूसरा जो है वो है नंबर्स ऑफ टर्न, नंबर ऑफ टर्न्स, राइट? हाउ मच टर्न्स आर देयर इन द कॉइल, इन द कॉइल. And then write two applications of EMI. EMI का दो famous applications है. One is your AC generator. ये long type भी question आ सकता है बोर्ड में. दोनों CBSE, ICSE कोई भी पैटर्न लो. And another one is your transformer. So my dear student, I am going to tell you that in my upcoming lecture, I am definitely come with this two long question, and hopefully all of you understand my today lecture. Thank you for your kind attention.